I want to show you guys how to solve some of the problems at the end there where it says write it out on a separate sheet of paper, and then you're going to take a picture of it and then upload that as your answer to the last one. So we've got this table here, and they tell us what element we're dealing with, and they give us what isotope it is, so the mass number and the atomic number there. They tell us the half-life for each of these. Notice some of them are big. Some of these numbers, by the way, 7.1 times 10 to the 8, that's the same thing as 710,000 years. 4.51 times 10 to the ninth, whenever you see times 10 to the ninth, that's like a billion. So it's 4.51 billion years. And then this one down here, 3.79 times 10 to the fifth. So that is like 379,000 years. Let's look at one of these. They give you an example, but I'm going to do it again anyway for hydrogen. Hydrogen, we're looking at H3. Hydrogen 3 is the isotope, and it says it undergoes beta decay, and that its half-life is 12.3 years. So let's do an example with hydrogen 3. So I'm going to write it down like this. Hydrogen 3, and write the mass number up here and atomic number here. It's going to undergo beta decay. It said that on the table. Remember, this B-looking letter is the Greek letter beta. So that lets me know right away that I'm going to spit out an electron from the nucleus. So I got to write that there. And then remember that beta decay means that a neutron turns into a proton. So the mass number stays the same, but since we gained a proton, that's got to go up to 2 there. Then you got to look in your periodic table and see who atomic number 2 is. You actually should know this from alpha decay, and it's helium. So hydrogen 3, through beta decay, is turning into helium. How long does that take? 12.3 years according to the table. So another way to look at it here is like this. If we had a sample of hydrogen 3, after 12.3 years, we would only have 50% of that hydrogen 3 left over. After another 12.3 years, we would only have 25% of our original left over. And then I'm going to loop around here. After another 12.3 years, we'd be down to 12.5% left over. I'll just do one more example. After another 12.3 years, we'd be down to 6.25% of our original sample left over. So that's another way to look at half-life decay there. Let's do one of the examples of alpha decay. So let's do polonium-210. So it says it undergoes alpha decay and it takes 138 days. So polonium-210, we'll write down PO for polonium. 210 is the mass number. Polonium's atomic number is 84, and it is going to undergo alpha decay. And so that means we are going to spit out basically a helium nucleus there. So 2 protons and 4 things overall, 2 protons, 2 neutrons. So alpha decay, always the mass number will go down by 4 because we spit 4 things out. So we will no longer be 210, we'll drop down to 206. Our atomic number is going to go down by 2 because we spit out 2 protons. So now we are down to 82. And you got to look up in your table what atomic number 82 is, and that is lead. And so you look up in your table, and lead is Pb, atomic number 82. Let's do one more here. I'll find another one. Let's do iodine 131. So that one, it says, was a beta decay. So I'll write this down. Iodine 131. And iodine's atomic number is 53. And it says it's going to undergo beta decay. So I looked that up. In beta decay, the atomic number stays the same, so that will stay 131. Excuse me, not the atomic number, the mass number stays the same at 131, and the atomic number goes up by 1 because we created a proton from a neutron. So you got to look up in your periodic table, what is atomic number 54? And it is xenon. So, and the symbol for that is Xe. So that is how you do these problems. So I've done 3 of them for you. There's a total of 11 on here, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. And so you are responsible for the other 8. If you have any questions, make sure you just jump onto the Zoom or message me on Schoology.